In this tutorial, we'll build this to-do list app with a React front end using Vite and a Django Rest Framework backend in a virtual environment. I'll provide thorough instructions, but if you do get stuck, I will pin a comment up top for discussing hurdles and sharing solutions. We'll transition from SQLite to MySQL, covering local setup and production deployment with AWS RDS. The tutorial includes a brief intro to AWS, installing MySQL Community Server, then installing and using MySQL Workbench for setup and management. I'm in VS Code, which is free and available for Mac or Windows. For this project, I created a folder on my computer earlier called TCF_to-do. This is going to be my working directory. You can create a folder anywhere on your computer for your working directory, but I would recommend sticking to the same naming conventions as me throughout this tutorial to make it easier to follow along. Once you have that working directory created, choose File, Open Folder, then Browse to and select your folder. I'm simply going to open my folder from my Recents tab. We can see our empty working directory here, which is named TCF_to-do. Now bring up the terminal window by clicking View and select Terminal, or you can use one of these keyboard shortcuts. I'm using a Windows machine, so some command syntax may differ if you are on a Mac, but I will usually give you the syntax for both operating systems. If not, you can find the equivalent Mac syntax via a quick web search. Before we get started, you will need Python installed. A quick check to see if you already have Python installed is to type Python -- version. This is applicable to both Windows and Mac users. You can see the version I have installed is 3.12.6. But if Mac users have Python version 3 installed, they will need to enter in Python 3 -- version. If Python is not installed on your machine, then simply download and install it from python.org. They have both Windows and Mac versions here for install. Let's start by creating a virtual environment to install our various Python packages. Make sure you are pathed to your root working directory, which is this TCF_to-do. The command is python -m venv. This is our virtual environment we just created, and it's called venv. Now we need to activate our virtual environment. So type in venv/scripts/activate. Your virtual environment is activated when you see this venv prefix before the terminal prompt. If that command doesn't work, then be sure to look up the proper activation command based on your machine and type of terminal you are using, since syntax can sometimes vary. Now we need to install all the necessary dependencies, but first we will need to create a list of those dependencies. So in your root project directory, create a file named requirements.txt. Next, I'm going to head over to my GitHub repo and copy the listed dependencies. You can do the same via the GitHub link I placed in the video description for you, or if you prefer, you can just enter them in manually. We're adding Django and Django Rest Framework, which is an extension of Django for building REST APIs. The CORS headers is just to eliminate any issues we may run into with CORS. The .env we'll get into later on when we add environment variables. And then the MySQL we'll get into later on when we swap over from SQLite to MySQL database. Okay, let's Control-S save this and close out. Make sure your virtual environment is still activated by verifying the venv prefix, then run pip install -r requirements.txt for both Mac and Windows. You'll see all of your new dependencies being installed. Let's make a new Django project. Pointing to our root directory, which is TCF_to-do, type Django -admin start project backend for both Mac and Windows. Take a peek in here and you can see our boilerplate Django project that was just created for us. There is another backend directory that was created, but keep in mind, these files are related to our base Django project. We can then create multiple Django apps, and we would need to wire our apps into these main project files. But these files are not where most of our coding happens. Most of our coding happens in the Django apps themselves. Go ahead and move your requirements.txt file into our root backend directory. Change into our backend directory that was just created with cd backend. Now, let's create our Django app within our project. As a side note, we name Django apps plural and we name Django models singular. Now type Python manage.py start app tasks. This just created our new tasks app for us. This is where we'll do the majority of our coding when creating the backend logic for our tasks app. But first, we will still need to wire this app into our project and update some overall Django project settings. In the backend directory, open this settings.py file. Add the following references within installed apps. We're going to add tasks, rest_framework, and CORS headers. If you're not already familiar with CORS, which is cross-origin resource sharing, enabling the headers in your Django project is essential if your application needs to interact with resources like APIs, front-end applications, or static files from a different domain or origin. By default, web browsers block requests made from one domain to a different domain for security reasons. CORS headers are used to allow or deny these cross-origin requests. Add a reference to CORS headers middleware within the middleware section. CORS middleware should generally be placed at the top of your middleware list. This is important for ensuring that CORS headers are applied before other middleware processes, especially those that handle security, authentication, or response processing. Now we need to specify which origins we want to allow, and we want to run our front end on localhost 3000. So add the following reference. This is a whitelist of all the CORS origins that we wish to allow. Then save and go ahead and close that file. Open models.py. First, we need to define our model. A model is part of the underlying Django framework and represents the structure of your database. Models are defined using Python classes that map directly to database tables, allowing developers to interact with their data in an object-oriented way. Throughout this course, I will comment my code. That way, if you grab any of the code from my GitHub, these comments will hopefully help you out. First, we're creating a model called task, utilizing the Python model class. Then we're adding a title field with a char field max length of 100 characters. Then we add a completed field, which is actually a Boolean accepting true or false. If the user does not provide a value, then we default to false. Then down here, we add a string method to return the title. And over here is where we actually return the title. We can save and close out of this file. In the task directory, create a file called Serializers.py. Now let's define our serializer. In Django, a serializer is a component that converts complex data types, such as Django model instances or queries, into native Python data types, like dictionaries or lists, that can easily be rendered into formats such as JSON or XML. It also works the other way around, by taking parsed data, for example JSON from an HTTP request, and converting it back into complex Python objects such as model instances, which can then be saved to a database. In our case, the API that we're building needs to be able to communicate requests and responses to and from both our front-end client and our database. So we need to be able to take this task Python object and convert it into JSON data. It also needs to be able to take the JSON data and convert it back to Python for proper communication. So we're going to create a serializer to do that. First, we import the Serializers module from the REST Framework package. Then we're importing the task model from the models file. Then we create a class called Task Serializer that links the task model to the task serializer. And then within that class, we create a class called Meta. We set the model to task, and then we set fields to all fields in the model. If we didn't want to include all fields, we could always specify each individual field that we do want to include. Now we're going to define our view, so open views.py. Views are classes or functions that handle incoming HTTP requests, process them, and return HTTP responses. Views define the logic of how your API endpoints respond to various actions, like get, post, put, and delete. They serve as the bridge between your model's data and Serializer's data representation to expose API endpoints. From REST Framework, first we need to import view sets. A view set is a class-based view that provides actions like list, create, retrieve, update, and destroy on a model. Then we're going to need to import our model, task, and then we need to import the serializer, which is task serializer. First, we need to create a new class called task view set. Then we're going to set the query set to return all tasks. Then we need to set the serializer class to the serializer we created earlier called task serializer. Then save and go ahead and close that file. Now create a file called urls.py in the tasks directory. A urls.py file in an app is where you define the URL patterns specific to that app. These patterns map URLs or routes to specific views, allowing the application to determine which logic to execute when a user visits a particular endpoint. First, we import path and include from Django URLs. This is for routing URLs to specific views in your app. Next, we import default router from REST Framework.routers for creating a router object to register our view set. Next, we import the task view set from the views.py file in the same directory. Next, we create a router object, which we've named router, to register our view set. Then we take that router object and we register our view set with it. Then we include the router.urls in the URL patterns list to make the view set accessible via the API endpoint /tasks. Then save and go ahead and close that file. Now include a task URL pattern directive in urls.py, which is located in the backend directory. First, I'm going to remove the comments. Import the include function from Django URLs. Then add a path to our URL patterns, where we're going to include the urls.py file in the URL patterns list from the tasks app. So anytime it is prefixed with /API/ in the URL, it will be routed to tasks app. Then save and go ahead and close that file. Open the admin.py file in the tasks directory. You need to register your models in this admin.py file in order to enable administrators to view, add, edit, and delete instances of the task model through the Django admin interface. It's a convenient way to interact with your data during development and testing. Pointing to our backend directory, let's run python manage.py make migrations. This analyzes the changes you've made to your Django model and creates migration files that describe these changes. It also created an empty SQLite database. These files are essentially a blueprint for how to alter the database schema. Now run python manage.py migrate. This applies the migration. It executes the SQL statements described in the migration files, altering the database schema. Let's create a super user in order to access the Django admin interface. So in the terminal, run the following. Enter in python manage.py create super user --username. And I'm going to enter in TCF for my username. You can enter in any username you'd like. I'm going to leave the email address blank, enter in my password, then enter in my password again. And your super user has been created. I'm going to go ahead and fire up Django's development web server by entering python manage.py run server. Now let's visit this URL by holding the control key down and clicking on the link. Let's enter in /API/tasks. We can enter in a couple sample tasks here. Now put in /admin and enter in your super user credentials. Now we're going to test out the admin interface. Click on tasks. I can see my first two sample tasks that I created. I'm going to add a third task. I've successfully added a third task through my admin interface. Now I'm going to go ahead and try to delete that second task. Success! To stop our development server from running in the terminal, you can typically use the Control-C keyboard shortcut on both Windows and Mac. Now I'm going to begin creating our React frontend utilizing Vite. If you're somewhat new to working with Vite React and would like to know additional information, I encourage you to also check out my Intro to Vite React tutorial. To create our app, you will first need Node.js installed. Here's their website. There are different methods of installing Node.js as you will see on their page, but the more popular method is to download the Node.js installer and install it that way. We also will be utilizing NPM, which is automatically included with Node.js. As with VS Code, it's completely free. We need to move back one directory into our root working directory, tcf_to-do. Run npm create vite at latest. Create Vite is a tool to quickly start a project from a basic template for popular frameworks. I'm going to enter in Frontend for my project name. Choose React for the framework. Next, choose JavaScript for the variant. Change into our new frontend directory using cd frontend. Enter npm I for install. This will install necessary dependencies like Vite and React. Now we need to install a few additional dependencies. So enter in npm I Axios. Axios npm is an HTTP client that simplifies making API calls. It allows you to send requests and receive responses as promises, which makes it easier to handle asynchronous requests. Now enter in npm i.env. This gives us the ability to load environment variables from a .env file. Now enter npm run dev, which will run our development server. By default, Vite uses port 5173, but we will end up switching this to utilize port 3000 instead, which is just my personal preference. If you click on the link while holding down the control key, we can open up our local host in our browser. So I'm going to bring up Chrome and we can see this landing page created by Vite. Now I'm going to stop our front-end dev server with Control-C. I prefer to use port 3000 for my front-end development. So from our new front-end project directory, open vite.config.js, which contains all our front-end app configurations. Here I'm defining our front-end dev server to use port 3000 instead of 5173. Within the src directory, create a folder named Components. This is a good way to organize our components in this folder. Then create a new file for your component. One important thing to note is that components in React always start with a capital letter, and it's common to use Pascal case, where the first letter of each word is capitalized. So let's go ahead and name this component tasklist.jsx with a capital T and a capital L. I'd recommend installing the React Snippets extension I just showed on screen to make things a bit easier. We can type in RAFCE to use the React Snippets extension. This creates a React arrow function component. I'm going to remove this React import at the top since the full library import was only required prior to React version 17. Let's put this text between some h1 heading tags. Now let's go into the root component of our React application, which is app.jsx. First, I'm going to delete these imports, then import the task list component we just created. Delete everything else in here except for an empty function, an empty return statement, and an empty export statement. Insert empty div tags. Now we can bring in our task list component object. Then enter in npm run dev. I've brought up Chrome next to our VS Code to make it easier to view our progress. Import useState and useEffect React hooks. These hooks will be used to manage the state of the existing tasks and the new task. Import the Axios library for making HTTP requests. This will define an asynchronous function called fetchTasks using an arrow function. Declaring it as async allows the function to use the await keyword inside. We are adding a try-catch statement so that if an error occurs during the request, the catch block will handle the error. This function makes an HTTP GET request to the server to fetch the tasks. The await keyword pauses the function until the request completes and the response is received. If the request is successful, res will contain the HTTP response object. If an error occurs during the request, the catch will handle the error. Here we're adding a React hook that uses the useState function. UseEffect is a React hook that runs a function after the component mounts. Inside the UseEffect hook, the function fetchTasks is called. An empty array as the second argument means that this effect will only run once. With that being said, I would like to point out React's strict mode in development can cause certain behaviors, like triggering UseEffect hooks multiple times to help developers identify potential issues in their code. This is not a bug, but an intentional feature of React's development environment. Strict mode can easily be disabled by going into the main.jsx file and removing or commenting out the strict mode tag. But this is usually not recommended. Plus, React strict mode will automatically be disabled in production build. The map function is used to iterate over the tasks array and render each task as a list item to display the list of tasks. For each task, a list item is created, and the task title will be displayed. Bring up our Chrome inspection pane and click on Console. Right now, the tasks that are being fetched are being output to the console. We can see our task array here, so this seems to be working properly. The reason why we see multiple renders in our console log is because strict mode is enabled. Now let's change console log to set tasks in our fetch tasks function. This way we can actually see our tasks render on our page. If we refresh Chrome, now we can see our tasks listed. Now we need to initialize another state variable called new task, which will contain user input for new tasks. Let's define another asynchronous function called add task. Here we're saying if the new task is empty, the function should return early and not add a new task. This HTTP post request is sent to the server. This request includes a JSON object with a key value of title and new task object. The input field allows users to enter the title of a new task. The value attribute is set to the new task state, which is updated as the user types. The onChange event handler updates the new task state with the new value entered by the user. The add task button calls the add task function when clicked. The add task function sends an HTTP post request to the server to add the new task. The placeholder attribute provides a hint to the user about what to enter in the input field. The response from the server is used to update the list of tasks displayed in the UI. Click Save, and now we can see our new add task input element and the add task button. Now I'm going to attempt to add a new task and refresh Chrome to make sure that that task is persisting. So far, so good. Now let's add a way to mark tasks as completed. This code defines an asynchronous function toggle complete, which is used to toggle the completed status of a specific task in a list. It sends a patch request to the server to update the completed status of the task. Whenever a user clicks on a task to mark it as completed or incomplete, then this function will be called via the onClick event handler of the task element, which we're about to wire up now. When the user clicks on the span, the onClick event toggles the toggle complete function using the task object as an argument. If completed is true, then put a strike through the text. If completed is false, then remove the line through. Save our component and let's test the completed task to see if it gets a strike through. Looks like everything is working as expected, so let's go ahead and add a way to delete tasks. This function takes the ID of the task to delete as an argument. When a user clicks the delete button next to a task, this function is called via the onClick event handler of the delete button. Now let's add a delete button where the onClick event calls up the delete task function, passing the task ID as an argument. Save your component and let's test it out. Okay, everything seems to be working as expected. Now it's time to style our React app. Since this tutorial is mainly focused on logic, we aren't going to delve too deep into CSS. I'm going to create a CSS module file, which is used to style components in a Vite React project. CSS modules are a way to locally scope styles, ensuring that styles defined in one component do not unintentionally affect others. Create a file in the components directory called tasklist.module.css with a capital T and a capital L. Next, I'm going to bring up my GitHub repo and copy the CSS styling from the tasklist.module.css in the components directory. You can do the same via the GitHub link I placed in the video description for you. Now paste in the CSS. In your React component, import the CSS file as a module. Vite automatically handles CSS modules when the file name follows the .module.css convention. So open the tasklist.jsx and import our CSS module by adding the following. JSX gets transpiled into JavaScript during the build process. And we can run into errors if we use the JavaScript reserved word class. So instead, we use the word class name to access our class. In our div tag, add a class name prop, then access the styles object so we can reference our scoped CSS class named tasklist. For the add task button element, let's access the add button class from our CSS module. Then for the delete task button element, let's access the delete button class from our CSS module. Click Save, and we can see our styling updated. If you don't have much experience with CSS styling, I encourage you to tinker with the styles in the CSS module. Keep your browser open at the same time like this, so you can easily see your changes take effect as you make them. If you have been following along from the beginning of this tutorial, then you will already have the two dependencies listed at the bottom of this requirements.txt file installed. I did want to point these two dependencies out for anybody watching only this part of the tutorial, where we'll be connecting to an instance of MySQL and then hosting our database with RDS, which is part of Amazon Web Services. These dependencies will be necessary for this portion of the tutorial, but if you have been following along from the beginning, then you already have these installed. Open inish.py from the Backend Django project directory. There is also an inish.py in the tasks app directory, but we want the project-wide inish.py file. Include the following. Import py MySQL. Django expects the MySQL DB library when connecting to a MySQL database. We're going to use PyMySQL as a drop-in replacement, PyMySQL is a pure Python library and easier to install and maintain. The line pymysql.install as MySQLDB tells Python to use PyMySQL wherever MySQLDB is referenced. First, we're going to be installing MySQL Community Server, which is the open source edition of MySQL Relational Database Management System. Visit dev.mysql.com/downloads. Then select MySQL Community Server. A few things to note about these versions you see. MySQL Innovation is about adopting the latest features and improvements in the database system, but can sometimes not be practical for production. And MySQL LTS, long-term support version, is often considered the best choice for production environment, where stability, reliability, and extended support are critical. With that being said, at the time of this video, version 8.4.3 is actually a brand new version. So even that version will give you a connection warning in Workbench, stating some features may not work properly. I haven't noticed anything noteworthy, and certainly for the purposes of this tutorial, we will not run into any issues. We will be using Workbench in this tutorial, but I think it's important to point out that Workbench is not the only game in town. A lot of people use MySQL Shell VS Code extension, including myself. It integrates MySQL Shell functionality directly in the editor. It allows developers to manage MySQL databases, run SQL queries, and interact with MySQL servers without leaving VS Code. Okay, let's move forward. I'm going to select version 8.4.3 LTS. I'm using Windows, so I'm going to stick with that operating system selected, and I'm going to utilize the Windows MSI installer. Run the install file. Choose Next. Accept the license terms. Choose Next. Typical installation. And install. Then click Finish. Choose Next. I'm going to stick with the default installation location. Default type in networking settings. Create a password for your MySQL root user. Enter in that password again. I'm also going to create an additional user so our application can utilize those credentials. This user will just be temporary for the purposes of this tutorial, so I'm going to call the user temp user. Then enter in your desired credentials. Select OK. Just remember to store your root user password somewhere, and also be sure to store the names and passwords of any additional users you create, because we'll be utilizing that throughout our application. Choose Next. I'm going to stick with the default settings for Windows service. I'm going to stick with granting full access to the user running the Windows service. I'm not going to create any sample databases. Now click Execute. Choose Next and click Finish. Your MySQL Community Server is now installed. Now that we have MySQL Community Server installed, I'm going to install MySQL Workbench. Workbench is a GUI tool designed for MySQL databases. It provides an integrated environment to design, develop, and manage databases. Head over to dev.mysql.com/downloads/workbench. Select your operating system. I'm going to choose Windows and then the Windows MSI installer. Run the install file. Choose Next. Choose Next again. I'm sticking with Complete. Choose Next. Then select Install. Click Finish. After any installations like this, it's always a good idea to restart your machine, so I'm going to go ahead and do that now. We need to create a new localhost connection for MySQL and Workbench, so click on the plus symbol. For the connection name, enter in task_local. Enter in whatever username you had created. I created temp user. It's up to you if you want to store the password in the vault or not. If not, it'll just prompt you, but I'm going to store mine in the vault. The password I had created for my temp user is capital TEMP, capital PASS1. Select OK and click Test Connection. This is the warning I mentioned earlier. We can just click Continue anyway. And our connection was successful, so click OK. Click OK again. We need to create an empty database instance, so click on this connection. In the query window, type in Create Database, TaskDB with a semicolon. Now click on the lightning bolt to execute that script. Refresh our schemas. We can see our empty database has been successfully created. Now we're going to connect to our local MySQL database we just created from Django. In your root Django project directory backend, create a file named .env. A .env file in a Django project is a text file that contains environment-specific variables, such as API keys, database credentials, and other sensitive information which you don't want to expose in your source code. Normally, you do not want to include a .env file in a public GitHub repository, but since this is temporary credentials for the tutorial, I went ahead and included the .env file in the project GitHub. Again, you can access that GitHub from within the video description link. I'm going to copy these credentials from GitHub and paste them into the .env. This states that we're connecting to localhost, which is 127.0.0.1. And that's the standard port 3306. That's the temp user that I created, along with the temp user's password, and TaskDB is the database that we created. So paste in these credentials and make any modifications. Now open settings.py and add the following references and database connection string. From .env, import load _.env. This loads the environment variables from a .env file into the environment, making them accessible in your application via os.getEnv. Import OS is used for managing file paths and environment variables. Load _.env, this retrieves our database connection credentials. Go ahead and comment out the database connection string for SQLite. You can grab our new database connection string from GitHub, or you can type it out. Our new connection says we want to use MySQL, and the os.getEnv retrieves our database credentials from our .env file. cd into our backend directory, run python manage.py migrate. Now open Workbench and refresh to see our data structure has been migrated over to a MySQL instance hosted on your local machine. Our task table made it into the database, and if we right-click and select rows limit 1000, we can see there's currently no rows because we need to add data. So go back to VS Code and run python manage.py run server. Control-click your link, add /API/tasks to the end of your URL, add a few tasks, read my email, do grocery shopping, open Workbench, right-click and select the first 1000 rows to see if our tasks have made it into our database. Our tasks have successfully made it over. Now I'm going to add another task, learn Django, and this time I'm going to toggle completed. Now I'm going to run the query that was created for us when we right-clicked and said select first 1000. Select star from taskdb.tasks_task, the star meaning all records. And this is the same as right-clicking on our table and saying select rows 1000. I can see there's a 1 for completed next to learn Django. So things are working as expected. We can close out of that database. In this portion of the tutorial, We will be deploying a MySQL database instance hosted with RDS, or Relational Database Service, which is part of AWS or Amazon Web Services. Some AWS services fall under the free or lower cost tier. However, it's important to note that AWS pricing can vary based on your usage and configuration. I recommend reviewing the pricing details for each service on the AWS pricing calculator. It is also helpful to turn off services when they're not needed. So first off, visit aws.amazon.com to log in or sign up for your AWS account. Users new to AWS can sometimes get a bit confused on the way they should log in. Here's a brief rundown of the different login options you may come across. First, there's the AWS root user. This account is created when you first set up an AWS account. Signing in as a root user, you will have ownership and access to all resources. Next, there are IAM users. These users are created and managed by root users. IAM users are for specific individuals or applications needing access to AWS resources. There's also a totally different type of account accessible by an AWS Builder ID. This is a new personal standalone identity to access developer tools and resources like AWS training and certification. These users are limited to these types of services though. AWS has a ton of services, but if you're new to AWS, just concentrate on one service at a time. When you log into AWS, you'll first be brought to your dashboard. This widget here shows my most recently visited services. Down here, I can click on all services. And then anytime I want to go back to my dashboard, I just click this AWS symbol in the upper left-hand corner. If you have an idea of the service you're looking for, just use the search bar. For instance, if I look up EC2, I can open it here, or I can also click on the star, which will keep a link to EC2 in my header. First, search RDS. We're going to add it to our favorites, and then select the link. Click the Create Database button. Stick with Standard Create. Select MySQL. I'm going to choose the free tier. Name your database instance Task DB. I'm sticking with admin for the master username. Enter in a master password. Confirm the password. For public access, I'm going to click Yes, since we're connecting from localhost. I'm going to click Create New for the VPC security group. I'm going to name it VPC-SEC-TaskDB. Now click the Create Database button. We can cancel out of that. Now we can see our TaskDB database and it says creating. We need to wait until it says backing up or created before we can grab the endpoint. This process usually just takes a few minutes. While we're waiting, we can bring up VS Code and go into our .env file. Copy our previous local configuration and rename the comment to hosted. Now we can comment out our original localhost configuration. Looks like my database status says backing up, so we can click on the database instance name now. Scroll down and click on the boxes to the left of the endpoint, and that'll put that endpoint in copy. Now we can go back into our .env and paste that endpoint in where it says DB host. Our port is still 3306. Our username, however, has changed to admin. The database name is the same, and I left my password the same. We can save and close out of that file. Let's bring up Workbench. Now we have our local database connection, but let's go ahead and make a hosted connection to our RDS instance. So click on the plus symbol to create a new MySQL connection. The connection name is going to be task_hosted. If you still have your database endpoint from AWS in copy, paste it into hostname. Otherwise, you can go back and grab it. Change the username to admin. It's up to you if you want to store your password in the vault or if you prefer Workbench to ask you for your password each time you connect. I'm going to store mine in the vault. My password was temppass1 with a capital T and a capital P. Click on Test Connection. Looks like we're successful. Select OK, then open up our new connection. Type create database taskdb semicolon. Click on the lightning bolt to execute the script. If we refresh our schemas, we can see we just created a new database called TaskDB in our hosted RDS instance on AWS. But we don't have any database tables in there yet, so let's head back over to VS Code. Bring up your terminal and move into the backend directory. Type Python manage.py migrate. Bring Workbench back up and refresh your schemas. Now, if you expand the tables group, you can see our task table down below. Right-click on that table and select rows 1000. You can see there's no rows yet. Let's go try to add some data. VS Code back up and type Python manage.py run server. Open up your development server URL with Control-click. Type in /API/tasks. I'm going to add a task called walk the dog. I'm going to add another task called feed the cat, but I'm going to mark it as completed. Now I'm going to go back over to Workbench and see if my data made it into the database. Execute our script. Both of our tasks made it into the database, and you can see feed the cat has a 1 for true since we selected completed. All right, let's go back to VS Code and add a super user. Control-C to cancel our development server. Type Python manage.py create super user -- username, and I'm going to call mine temp user. I'm going to click enter to bypass the email address, and you can enter in any super user password you'd like. Re-enter your password again. Start our development server again with Python manage.py run server. Go to our development URL. Type /admin. Enter in the super user credentials you just created. Click on tasks. I'm going to click on the walk the dog task and change it to completed. I'm going to change feed the cat to feed the black cat. I'm going to add a few more tasks. Learn MySQL. Mow the lawn. Everything seems to be working fine here. So let's go back to Workbench. And if we execute that script, we can see that our CRUD operations are working great on the hosted database. Now let's try making database transactions from our React front end. Click on the split icon and VS Code will open up an additional terminal window. The terminal to the left is still running our development server for our backend. We want to run our front end development server on the right hand side. So let's change into the front end directory. Enter npm run dev. Control-click that URL. And we can see that our current tasks are persisting in our React client. I'm going to add a task, learn Python. I'm going to refresh and I can see that task is persisting. Now right-click and choose Inspect and click on Console. Only errors that happen after you open the inspection window will show up. So let's refresh Chrome and see if we get any errors. So far, so good. I'm going to add another task and see if we get any errors. Host this app on AWS, EC2, and S3. Okay, no errors, and our app's working great. This tutorial is actually the first half of a longer video. In the second half of the longer video, that's also free, we take this application and host it by creating an AWS EC2 Ubuntu instance and deploying our backend Django project. We will set up an Nginx as a reverse proxy server acting as the first point of contact for our client requests, which will include SSL via certbot and Let's Encrypt. We will also be implementing a Gunicorn socket and service for our Python WSGI server. I'll walk you through creating an AWS S3 bucket to host our React frontend, along with creating an AWS CloudFront distribution for handling HTTPS with Amazon Certificate Manager, caching, and content delivery from the S3 bucket. We will be creating a Route 53 hosted zone and implementing a custom domain. I will even show you how to transition your name servers to Route 53 from services like GoDaddy. I left a link to the full tutorial in the description for this video. Just follow the link and go directly to the chapter titled Host This App, since you have already completed the first half of the tutorial with this video. I really hope you enjoyed this tutorial. If you did, it would be awesome if you could like, subscribe, and click the notification bell. See you soon.